Hello students, I am Swaraj, contract lecturer in ECE, GPT, Nizamabad. So let us recap the topics we are discussed in the last lecture. It is working of GNR regulated power supply, determine the resistance value and voltage of series resistors. Limitations of series voltage regulator, GNR diode for a given input voltage, load voltage and load current. And we discuss negative feedback voltage regulator and positive feedback voltage regulator. And simple transistor shunt regulator and IC voltage regulators we discuss. So let us recover today what we are going to discuss. That is, on the completion of this period, we would be able to know what is the data sheets and commonly used diode numbers and applications of diodes. So these are going to we are going to discuss in today's lecture. So data sheets and commonly used diode numbers. So this data sheet gives the entered IC numbers, ratings and characteristics of this semiconductor diodes. So the IN 400 X series is a family of popular 1 ampere general purpose silicon rectifier diodes commonly used in AC adapters for commonly household appliances. So these are the number is IN400X. This is a one series of the diodes, semiconductor diodes, and which is used in the home household applications and AC adapters. Whereas IN540X series is similarly popular family of diode for high current 3 amperes applications. Whereas IN400X is used for the 1 ampere applications and IN50X is used for the 3 amperes applications. So these are the two series of diode series. In this we have the different numbers for each and every series and each and every diode having different ratings. So this is a data sheet of IN400X series. So here the peak repetitive reverse voltage and working peak reverse voltage DC blocking voltage is given. So the symbol is where is using peak repetitive reverse voltage is RRM and working peak reverse voltage is RWM working voltage and VRS reverse voltage. So this IN4001 it is having 50 and IN4002 100 and IN4003 200 and IN4004 400 and IN4005 is 500. So that is number is IN4005 is 600 and 6 is 800 and 7 is 1000 and the units for this one is volts. So this is a reverse voltage where peak reverse voltage and the peak inverse voltage we can be expressed in the terms of voltage. And RMS are the reverse voltage. So VR is reverse RMS voltage. Reverse RMS voltage for the IN4001 is 35 and 4002 is 70 and 140, 280, 420, 560, 700. So approximately it is double for every series number is increasing 35, 70, 140, 280. So here how to get 560. So from this one 4 to 6 we are getting 560 and here 700. Just here this only some variations, but up to 4 IN 4004 is doubles. And average rectified output current at temperature 75 degree centigrades. So that is IO, that is output current. Rectified output current is 1 amperes only. So this is a rectifier IN 400 is for the 1 ampere rating. And non-repetitive peak forward surge current 8.3 millisecond single half sine wave superimposed on the rated load. This is IFSM forward surge current is 30 amperes. And forward voltage at forward current is 1 ampere is 1 voltage only. Forward voltage at forward current of 1 ampere is 1 voltage only. And the peak reverse current at the temperature is 25 degrees centigrade at rated DC blocking voltage is 5.5 microamperes and blocking DC blocking voltage is 50 volts. Okay. And the typical junction capacitance C1 is equal 50 microamperes and 8 microamperes. 15 microamperes and picofarads, 15 picofarads and 8 picofarads. And typical thermal resistance junction to ambient, that is 100 kilowatts. In maximum DC blocking voltage temperature is plus 150 degrees centigrades, and operating and storage temperature range is operating temperature, and this one is storage temperature TJ to TSTG minus 65 to plus 150 degrees centigrade is. That is the operating and storage temperature range for the IN 400X series. So this maximum temperature is at the rate at TA is equal plus 25 degrees centigrades unless otherwise is specified. If we are not specified, we can be considered as a 25 degree centigrades. And maximum ratings and electrical characteristics of the data sheet of IN 540X series, which is rating for the 3 amperes. So here the same characteristics: peak repetitive reverse voltage, working peak reverse voltage, DC blocking voltage. We can be specify VRRM, VRWM, and VR. So these values are 50, 100, 200, 400, 600, 800, 1000. Compared to this one is, it is having high voltage ratings. Compared to this IN40X series, 400X series, it is having high voltage ratings. Compared to the same, it is very similar. Each other having the same similar values, where it is having this also same values 50, 100, 200, 400, 600, 800, 1000. So these also having the same repetitive reverse voltages and peak reverse voltage and blocking voltages. The equal for the IN 400X and IN 540X series. And this RMS reverse voltage VRS also 35, 70, 140, 280, 420, 560 and 700. This is also very similar to the IN 400X series. And next one is average rectified output current at the temperature is 105 degrees centigrades. But whereas it is IN 4406 is we have considered at temperature 75 degrees centigrades only. So here it is 105 degrees centigrades, and this is a rating for the 3 amperes. So this is the change in this one compared to this 400X series. And non-repetitive peak forward surge current 8.3 milliseconds, single half sine wave superimposed on rated load is 200 amperes. That is IFSM. This is through 200 amperes, but whereas it is very high compared to this 400X, which is having only 30 amperes. And this forward voltage at forward current 3 amperes is 1 voltage only. But whereas in the 4006 forward voltage at forward current of 1 ampere is only 1 ampere. But it is 3 ampere at forward voltage at forward current of 3 amperes is only, again we are getting 1 voltage only. And this peak reverse current at temperature 25 degrees centigrade at rated DC blocking voltage at TA 150 degrees centigrade is equal to 10 and 100 microamperes. At temperature 25 degrees centigrade is 10 amperes, and at temperature 150 degrees centigrade is 100 amperes. But whereas in IN 4006 is 400X series is 5 microamperes and 50 microamperes. So it is double compared to that one. And typical total capacitance is 50 picofarads and 25 picofarads. It is also increased in this one. And typical thermal resistance junction to ambient is 15 degrees centigrades per watts. Whereas in that one is in kelvins per watts. And this operating and storage temperature range is minus 65 to plus 150 degrees centigrades. It is also similar to the again 400X series. Same values. And the commonly used diode numbers we are using for which applications we are using which type of the diodes. First one is BAV45. That is the name identification number of the component, that is the diode. So here this diode is used for the clamping, holding, peak follower, time delay circuits. So we are using in the clamping circuits, holding the peak followers, that is a maximum peak up to following, and the time delay circuits. In the circuits we use the BA4 BAV45, whereas BAW62 silicon planar epitaxial diode, this is we are using for the fast switching in the applications. And 0A90 germanium point contact diode. This is the type of the diodes we are using. This is used for the video detectors to detect the videos. And the next one is OA47 germanium gold bonded. This is used for the switch also. And IN914 germanium whisker high speed switch. It will be acting as a high speed switch where we are using in the applications. And IN4151 and a silicon whisker which is used in the military and industrial. And IN4001, IN4002 and IN4007 silicon which will be acting as a ordinary rectifiers. This we are using in the our laboratory purpose. And BA102 silicon diode can be used in the applications of variable capacitors. And BB104B silicon planar, which can be used as applications in the variable capacitors, FM tuners and double diode. And BB113 is in an applications of triple variable capacitor frequency controls. So these are the identification and number of the components, and these are the diode can be identified the diodes by using this numbering. And these are the applications of these three diodes where we are using. And use of PN junction diode. So these are the applications of the diodes where we are using and how we are using to in the different applications. So one is protection against polarity reversal, and another one is power control of soldering irons, and third one is dimming of incandescent lamp and temperature sensors. So these are the four applications of the PN junction diode. Let us discuss. The first one is protection against polarity reversal. So these are the two ways we are connecting here the diode. This diode. First, you can wire a relay switch to pass power to your system with no power loss. Here we are using one relay. Here it is, and we are connecting one LED to control this one against the polarity reversals. So here we are using the different diodes. That's 5-4 series. The two diodes are connected to the power supply. One diode is connected to the relay. And here the D2 clamps inductive kicks from the relay circuits. So this diode D2 is used to clamp the inductive losses in the relay circuits. Here the figures show with reversed input voltage, the relay switch engages interrupting power to the system and the LED lights. So here we are providing the switch is connected to reverse. This input voltage is reversing this. Here it is. Here it is a positive voltage we are applying, and here the polarity of the input voltage is reverse. So let's what will happen in the circuit. Common method of reverse voltage protection employs diode to prevent damage to a circuit. So common method of reverse voltage protection implies the diode to prevent the damage to the circuits. So if you are providing the reverse voltage to any diode, that will be damage the circuit. Select a relay to operate with a reverse polarity voltage. For example, use a 12 volts relay for a 12 volt supply system. So you are using the relay for the 12 volts. So you are using the 12 volts relay. That is 12 volts. Here it is mentioned. That is a relay. No connections and make the connections. So this is uh, when you apply a correct polarity to the circuit, D1 becomes reverse bias and the S1 relay remains off. So when you are applying the correct polarity, D1 will become reverse bias. So here this is a normally we are applying the polarities. Here it is. So this D1 is having the negative polarity. So then the diode will be remains off. So then the relay will be in the off state. Then connect the input and output power lines to the normally connected pins of the relay. So input and output power lines to the normally connected pins of the relay. So current flows to the end circuit. Diode D1 blocks the power to the relay and the protection circuit disappears, no power. So here this D1 is blocks the power to the relay. Here this D1 is blocks the power to the relay while because it is normally in the off state. When you apply incorrect reverse polarity, diode D1 becomes forward bias and turning on the relay. So now if the D1 will become reverse bias. If you are applying the reverse polarity, so in the circuit, you are applying the reverse polarity. So you are applying the positive polarity. So then it will be forward bias. Then it will be conduct. So what will happen? Turning on the relay. So the relay will be on. Turning on the relay cuts the power supply to the end circuit. And red LED D3 turns on, indicating a reverse voltage. So here this LED will be turned on. So then it will indicate the reverse voltage is applied. Here it is. This circuit consumes power only if the reverse polarity is applied. Unlike FETs or semiconductor switches, relay contact switches have low on resistance, meaning that they cause no voltage drop between the input supply and the circuit requiring protection. Thus, the design is suitable for systems with tight voltage margins. So, the circuit consumes more power only if the reverse polarity is applied. So, this is the condition when you are applying the reverse voltage. So unlike FETs and semiconductor switches or relay contact switches have low on resistance, so meaning that they cause no voltage drop between the input supply and the circuit requiring protections. So to protect that one, it will require the protection circuits where there is no losses in the input circuits with the no resistance or the low arm resistance. So then next one is the under this second application is the power control of soldering irons. So in the first one can be used the first one we can use the power control protection against using polarity reversal. So in this one we can be connect the diode in between the battery and the voltage. So this reverse voltage protection circuits prevents damage to power supplies and electronic circuits in the event of reverse voltage applied at the input or the output terminals. So this is the reason. So to block the negative voltage, designers usually place a power diode in series with the power supply. The simplet circuits under the normal condition, the diode is forward biased. Under reverse biatory conditions, the diode is reverse biased and no current flows and that protects the load. Whenever we are connecting the diode in series with the battery and load. And next one is the power control of soldering irons. So this is the circuit diagram we are showing that the soldering iron operates at 1/3 power in the simmer position. So here we are using one soldering iron is connected, here it is. So this is the output is the rectifier, this is half wave rectifier, we are showing it, here it is. This is AC input, we are connecting the transformer, and this is the output voltage is applied to the rectifier sector. At the output voltage we are having the some rectified output which is having the some ripples, that is a 1.4.1 into 5 into Vn, that is the peak voltages. So here, so this is a rectified output is applied to the one soldering iron operating to operate the soldering irons. This is the output voltage we are applying to the to operate the soldering iron. So here figure shows the basic half-wave rectifier circuit can be adopted to give two-level power control of lamps, electrical reels, and soldering irons that are operated from the AC power lights. So instead of applying the main AC supplies, we can be operated using the rectifiers in between the soldering irons and AC mains. So here the figure shows the basic half-wave rectifier circuit can be adapted to give two-level power control of lamps, electrical reels, and solderings. So in place of this soldering iron, you can be connect lamp or the any heating element also. This circuit shown in figure uses a soldering iron heating element as its load. So at the load we are connecting, here it is. This load, this is a load. At this load we are connecting, here it is a soldering iron. And these have a resistance that increases moderately with temperatures. So here in the soldering iron, the resistance will be increases moderately with the temperature. Thus, when the iron is operated at a half voltage, its resistance is slightly reduced. And net effect being that the iron operates at about 1/3 of maximum power when S1 is in the simmer position, thus keeping the iron heated but not at such degree that its bit deteriorates. So here this will be using in the simmer position, so it will not be heated completely. Note that in the figure, the circuit D1 can be any type that has a current rating matched to the load requirement and with peak in reverse voltage rating at least 1.41 into VN. So that's a diode, whatever the diode choosing in the rectifier, it can be type that has a current rating matched to the load requirements. Soldering iron, here we are using the soldering iron. So what is the current rated requires? We have to choose that one type of the diode and the peak with the peak reverse voltage of 1.41 into 10 into V. Otherwise, you can be connect the diode with a double pole single double pole double throw switch also we can be used in place of this, using this 1, 2, 3 variations, that is single pole and multi throw. So here whether this diode is converting the alternate current into the direct current by removing the negative half cycle of the AC current wave. So here it is remove the AC half cycle AC currents, we are removing the negative half cycles. So this type of diodes are used in double voltage soldering iron to reduce the power supply to approximately half the original signals. We use the diodes in the soldering iron to reduce the power input to the circuit. So we are using the soldering iron to reduce the power input to the circuit. Generally, while using soldering irons, we have to constantly switch it on or off using power strip to the control to its temperature. So it does not get too hot. So it will not get too hot. To reduce the power input to the iron, we use the diodes in series. So we are connecting the diodes in the series to reduce the power input to the iron. And third one is dimming of incandescent lamp. So here this is a circuit of we are using. This is output from the rectifier output, or you can take the AC main supply. So this having the three-way switch, and we are connecting here. It is one lamp, and this is a characteristic for the temperature sensing. So the figure, the circuit uses a lamp load. Here we are using in the load we are using one lamp which has a resistance roughly proportional to its filament temperatures. So you just say lamp load which is having a resistance roughly proportional to its filament temperature. When it is operated at half of the maximum voltage, its resistance is only half of the maximum. So the lamp operates at a bulb at about a half of maximum power and thus burns at half brilliance with S1 in the dim position. So this one is when it is one is off, in the position it is one, it will be off, and it one position it is one, it will be operated with the D1 diode 1, and it is 1 is S3 is 1. When S1 is 3 position, it will be diode will be in on position. So whenever it is in the dim position, the lamp operates at about half of maximum power and thus burns at half brilliance with S1 in the dim position. So it half of maximum power only it will be consumes. When it is operated at half of the maximum voltage, its resistance is also only half of the maximum of the load only. So this type of this dimming lamp, incandescent lamp also can be used. These incandescent bulbs and halogen bulbs will work with any dimmer, and while the dimmer can be of the less expensive variety. So this is used to either to switch on or the switch off the incandescent lamps. And another one is temperature sensing. The application of this one is temperature sensing. One of the simplest thermometer to use is the diode thermometers. We are using to sense the temperatures. The forward voltage drop across a semiconductor PN junction falls as the temperature falls. So here the forward voltage across the PN junction will be decreases as the temperature decreases. For certain semiconductors, the dependency is relatively linear over significant ranges of temperature, and hence such diodes are quite useful thermometers. So for certain semiconductors, the dependency is relatively linear over the significant ranges of temperature, and hence such diodes are quite useful thermometers. So here the diode can be used to sense the temperature due to the change in their flow of cut voltage with change in the temperature. As the temperature increases, the, ex, the change in the as the temperature changes, The drop across the voltage also will be changes. So here, this we are having the characteristics for this temperature sensing. So here, this temperature is decreasing, power as the voltage is increasing, decreasing, the temperature is also will be decreases. The two commonly used semiconductors for this purpose are gallium arsenide and silicon. Note that silicon diodes are cheaper and more reliable than the gallium arsenide variety. The diode thermometer can be used over a wide temperature range, typically 40 to 400 K, though the measurement may be extended down to 1 K if the diode is calibrated more carefully in this low temperature region. Generally, a measurement current of between 1 and 10 amperes is used when the voltage being measured on a digital voltmeter. A very simple measurement to make. The sensitivity of the device is around 2 meter to in the linear region is around 2 meters pk in the linear regions. The stability of diode is limited to about 0.1 K, but better reproducibility can be obtained if carefully selected diodes are used. Figure shows the voltage temperature curve for a of a typical gallium arsenide and silicon diodes. So this is the characteristics for the two diodes. So the topics we are discussed in this, we have discussed about data sheets and commonly used diode numbers. So we discussed the data sheet of IN 400 X series, the different parameters and the values for this one, and IN 43354 IN. We discussed the this. What is that one? IN 540X series and IN 400X series. So these are the two series we discuss right now, and the commonly used diode numbers and applications of diodes. So we are having applications of diode. We are having protection, power control of soldering iron, protection against polarity reversal, and dimming of incandescent lamp, and temperature sensing. These are the four topics we are discussed in the applications of diode. And the frequently asked questions on this topic is list the commonly used diode numbers. We have discussed the BA, BAV45, BAW62, 0A90, OA47, IN914, IN4151, IN4001, 4002, IN4006. So these are the IN4001, 4002 and 4007 all comes under the category of 400X series. And BA102, BB104B, BB113. These are the commonly used diode numbers. And explain the working of protection against polarity reversals. This is one question which we are discussed in the applications of diode. And next one is explain how diode used for the power control of soldering iron. This is also one application. And explain how diode used for temperature sensing. One more application. And explain the application of diode for dimming of incandescent lamps. These are the frequently asked questions are having chances to occur in your exam point of view. Next, let us discuss some simple questions on this one. The order of reverse current in a diode is. reverse current. Whenever it is reverse bias, the current flowing through the diode we call as a reverse current. So this is the topic discussed in the third chapter. But whatever we are discussing in here, the applications of diode. So just let us discuss some simple questions on this one. That order of reverse current in diode is either it is in amperes, microamperes, milliamperes, kiloamperes, all of the above, none of the above. So order of reverse current. So whenever it is in the forward bias, it will be in the milliamperes. But whenever it is reverse bias, it will be in the order of small current only. Small amount of current will be flows in the reverse bias, that we call it as a microamperes. Amperes is large value, kiloamperes is large value, milliamperes I say compared to this one is small value, but it is microampere is the small value, that is the answer is B. And next one is, when an ideal crystal is forward bias in this one, which behaves as perfect forward bias, that is the condition is forward bias, then it behaves as perfect insulator, resistance material, conductor, transformer, all of the above and none of the above. So diode cannot be, here it is not, diode is a forward bias, means it is not will be acting as an insulator. Why? Because whenever the diode is forward bias, the current will be flows. So it is not insulator. And resistance material, it will not be acting as a resistance material and conductor. So whenever the diode is in forward bias, then it will conduct, the current will be flows. So diode will never be acting as a transformer and all of the above, none of them. So among these, so whenever the diode is forward bias, the current it will be conducts and the current will be flows to the diode. So the option is, so correct answer is C. The next one is, the function of Zener diode is. What is the function of Zener diode? So we discussed in the Zener diodes. So this Zener diode can be used as a, only it will be conducts in the that is where in the reverse polarity, the reverse supply only it will be conducts. That is Zener diode. Compared to the normal diode, the Zener diode can be operate in reverse voltage also. So the function of the Zener diode is current amplifier. So this diode cannot be, Zener diode cannot be used for the amplifications, and voltage amplification is also not possible, and it can be used as regulators. So we discussed Zener diode as a voltage regulator, series regulators, shunt regulators, and the transistor with transistors. We discussed, that is the types of the regulators, and we have the positive regulators and negative regulators also. So that is only we discussed with the Zener diode, and all of this, right? Answer is only Zener diode. The function of the Zener diode is to regulation only we will use. That is, we have the series, that is 7408, 1408 series. Like this, we have the different series. We will discuss that series will be later. So these are the questions related to diodes. So today's topics we discuss. So this one is, we discuss the data sheet of diodes and applications of the diodes and simple questions on this one. So this is data sheet, and we have to remember some more, few or more values in this one. And applications of diode is very important. That is protection against polarity reversal, power control of soldering irons, dimming of incandescent lamps, and temperature sensing. So, and we have the how that diode is used in the protection against the polarity reversal. That is how we are connecting the diode across the relay and in the positive supply and in the negative supply. So these are the topics we have discussed. And in this one, power control of soldering irons, how this load is connected across the rectified in output, and by using the switch, how we are connecting the soldering, how we are controlling the soldering irons, and how we are controlling the lamp across the uh, across the supply voltage by using the switch and diode, and how we are connecting the temperature sensing to control the temperatures by using the different types of the diodes, which is the gallium arsenide and silicon diodes. So thank you. By this today lecture will be end. Thank you.